Hey guys, just going to run through the development of this surface C for you. So, as said in the last video, just remember development is essentially a true shape of each one of the surfaces you're asked to develop, joined together. Okay, so for this they're asking for the development of the transition piece. So basically this full piece. Okay, none of these 5 pieces or 5 shapes are true shape as it is, so they're all going to change in size somewhat. Okay, this one we've already found the true shape of by rotating it, or whatever method you've used to get the true shape of it. So I need to join this onto the side of this, because it's joined up onto this edge, which is now this edge. So again, I can see 2, 3 has this rectangle joined onto it, so 2, 3 is going to have the rectangle joined on here. Okay. One of the differences is this edge 2, 3 is now a true length. Okay, which means it is longer, as you can see easily, than it was there, because there it's sitting at an angle. It's running away from us here, sitting flat on the ground. Okay. Now this surface here, that rectangle. Okay, what do we know about that? Well, so far I know this distance from there to there, or from there to there, they are true lengths. Okay, so I know that happens to be a true length. Okay, how do I know that's a true length? I know it's a true length because in the front elevation, that appears as a point for you. So obviously it's a horizontal line. Okay, this point here going from 3 back, it appears as a point up here, which means that that is a horizontal line. So on the plan, that's a true length, and that's a true length. So at least I know this for this rectangle, that's the longest side on it, and then this distance is going to come out here, and the same over here. Okay, now this is going to stay as a rectangle. Okay, if I have a rectangle which obviously has 4 90-degree corners on it, okay, and this line here is a true length line, so this line is sitting horizontal like that. Okay, as I rotate that rectangle up and down from where it is, right, looking down top of it, because it's rotating about a true length line, all these angles will still remain the same, so they will still remain 90 degrees. Okay, so even if you get, and it's not by me trying to do this really on the camera, it won't work out right, but if I'm taking something like the coaster there, which is pretty much square, okay, each of the corners are 90 degrees, as I'm looking down on top of that, if I can do it here with the camera, as I rotate it, so if this is sitting horizontal, that's a true length, that's a true length. Okay, so sorry, let's put it this way. As I rotate that surface back up this way or back down that way. Now the problem with the camera is perspective starts to throw things off. These angles will remain at 90 degrees. Okay. So this 90-degree angle here and here and here and here, they're going to remain 90 degrees as this comes out this direction. Okay, so 90 degrees to that edge there. So the easiest way, or the way you would normally do it with a development question, I suppose this depends on how much you did in developments for junior cert. I'm quite close to the camera here, just to realise that. So I'm going to take that length there and just transfer it out that way. So all I'm doing is taking that length, bringing it out this direction. Okay? As I said, I know that. Try to square up there. So I know that this is going to come out 90 degrees to that edge. So from point 2, it's coming out to meet that little arc there like that. Okay. From point 3, bring it out that way. And then finally, those 2 edges are going to be parallel. So remember the rule, if 2 lines are parallel in one view, they'll remain parallel in all other views. Okay, so that line and that line are parallel. They're going to remain parallel here. Okay, so that now is the true shape or the development of that piece. Join onto the edge of this. Now, this line here should be a dotted line. Okay, because anytime we do fold lines on a development question, those lines become dotted lines. Okay, so that's that piece. Go over to this side, I can see that on C, A is joined onto it. Okay, it's joined onto the edge 1, 4. Here's my edge 1, 4. 1, 4 we know is now a true length because we folded it down flat. It's a true shape. Okay, so 1, 4 is true length. I'm going to do the exact same thing with this. So the same thing applies. That surface A is a rectangle or a rectangular surface. Each one of the corners are 90 degrees. Horizontal in front elevation, therefore horizontal, or true length and plan. Horizontal in front elevation, therefore true length and plan. Okay, these 90-degree angles are going to remain as 90-degree angles. Okay, so same as I did on the other side. I'm going to take that and I'm going to rotate it out like that. And then I'm again going to set up at 90 degrees to the edge 1, 4. So that's going to come out as far as there. So again, all I've done is made that distance the same as that distance. Okay, I'm out from 4. Same thing again, and this one I can actually put in dotted. So the other line there, 1, 4, that should also be dotted. This is dotted back as far as there. Okay, so that's the development of surface A. Okay, and again, when I say development, basically true shape, true shape, true shape. Okay, now for the next bit, surface B is going to be the same size as surface C. So basically this shape here, which is surface C, that should be brought down here. Okay, this shape here is going to be the exact same as this shape here. So in other words, it's going to be the same size as this one, and that's going to go down here. Okay, there are loads of different ways of doing it. If you want to look at the fact that the angle that's contained there, whatever angle that is going to be the exact same angle contained there, you could, if you wanted to get your protractor, measure that angle, measure it here, bring that line out here, take that length, mark that length down there. Okay, so you could do it that way. The angle contained here is going to be the same angle contained there. That length is going to be the same. Okay, so you could do it that way. What I'm choosing to do with this is use symmetry to move these across. So because these objects are symmetrical about a center line, or symmetrical about point A, if you want to look at it that way, okay, I can take just even that point there, point 3 is going down this direction. Okay, so if I wanted, I could put a center line directly on the middle of A, or I can take and just extend that line, just make it a little bit heavier out there, and extend that out there. So the distance from here back as far as 3 is going to be the same distance from here out as far as the 3 out on this one. Okay, obviously point 1 is going to be the same place, but other than that, set up 90 degrees. My corner up there is going to be down along here. Okay, so again, I could take the distance from here back as far as 2 and mark it from here down as far as a new location for, we'll say 2 on surface B. Okay, and basically other than that, I'm going to do the very same with that other small surface there as well. So just to show you, now again, I could use a center line in the middle of surface A to mirror this across. So there's that distance there, which I'm going to mark out to here. I'm going to call that surface 3 just for the sake of keeping some sort of similarity between the two surfaces. So distance out as far as 2. Bring it over as far as here and mark it out there. Okay, so I'm going to join these back up in the exact same way. One goes as far as 2. So I'm just calling that point 1 again. 2 goes as far as, where are we going to? 1 goes as far as 2, 2 goes as far as 3. And 3 goes back as far as 4. Now things will have stayed the same if you check them. that line and that line will still be parallel. Okay, they're parallel in this view. Okay, so they're going to be parallel in this view. Okay, the last thing to do, this rectangular surface is going to join onto this edge here. Is going to come out this way. Okay, so there's a couple of different ways of doing that. What I did on my own solution is just brought these guys out at 90 degrees there, 90 degrees there, and then if you can, just go perpendicular to that surface like that, and that gives me that point, and then these two edges are parallel. Okay, so that's sitting in there. So that is how you do the development for that. It's taking longer than I kind of thought it would, but anyway, that's the exact same size as this one up here. So again, I use symmetry to bring those across, but you could use a protractor and angles and lengths of size. Doesn't make any difference as long as you end up with the actual size down here. Okay, and it works okay for this one because I know these two are the same size and I know these two are the same size. Okay, have a look at it, see what you think. I will do a separate video for the cutouts in these surfaces. Okay.